Hi, and welcome to Thermodynamics 4. This lesson is very theoretical, even for a physics lesson, and is going to introduce two cool ideas that we have in thermodynamics, the heat engine and the heat pump. So these are theoretical ideas, but it turns out they're actually really useful and really helpful. So let's start with the heat engine. A heat engine is when heat is flowing the way that heat pretty much always flows. It just flows from hot things to cold things. That's what heat does. You've got a hot thing, the Q's just going to flow to a cold thing. However, sometimes we can get useful work coming off it. Very simple example. You've got a hot cup of tea. You can get one of those like paper turny things, like the sort of wind chimey, the sort of you know what I mean, the twirly things. You can get one of those and hold it in the steam, and it will slowly rotate as the hot steam comes up. This is an example of a heat engine. And as something is cooling, you're getting useful work out of it. There's lots and lots of examples. Coal-fired power station is a heat engine. You heat up the water. As it cools, you run it through a turbine, you get your electricity off. Steam engine, also. Nuclear power plant, doesn't matter. Wherever we're sort of generating useful work, you'll find it's a heat engine. But there's a more interesting side to this, which is it turns out that whenever you get useful work coming out of something, it's always a heat engine. Every single thing in the universe that produces useful work, and by useful work we basically mean any sort of energy that is not heat energy. Something electrical, kinetic, magnetic, any of the, the fun ones, the useful ones, it'll be a heat engine. Somewhere, something in it, heat will be flowing from hot to cold. Even within inside your own mitochondria, bonds are breaking, there are exothermic reactions happening inside them, so that even you walking up the stairs is a heat engine. Work can only happen when something is cooling down. This turns out to be a really kind of bedrock idea within the universe, which is why the heat death of the universe I discussed the other week is so total. If everything is the same temperature, heat cannot travel from hot things to cold things, meaning that no work can ever be done. In a universe where everything is the same temperature, there is no kinetic energy, there is no chemical energy, there is nothing interesting happening because there are no heat engines. However you say, sometimes we can get heat to flow the wrong way. We can warm up a cold room. We can boil a cup of tea. We can do lots of ways where we can get heat to go the other way. But you will notice, whenever we do that, we have to use energy. How do we know it takes energy to heat up a room? Well, the energy company will charge you for it. Yeah? How do you know your air conditioner, which is also what we call a heat pump, anything which moves the Q in the wrong way? Think about it really carefully. Air conditioner, you want the room, which is warm, yeah, to be getting colder, so now you're wanting to pump heat the wrong way to how you would expect. It's a heat pump, and they all take work in. It takes work to pump heat from cold to hot. The air conditioner is the classic example, and it's really neat because it works like this. In the summer, you want your room to be colder than the outside. So you want a cold room pumping heat to the hot exterior. So you're moving heat the wrong way, which is why it takes work. Interestingly, in the winter, you want to take heat from the cold outside and pump it into your hot room. So again, you're moving Q the wrong way, which is why an air conditioning unit can both be used to cool you down and heat you up. It's exactly the same process. It's just moving heat from cold to hot and putting energy in. You've got to keep putting electricity in. And finally, just to make the argument completely airtight, where did this work come from inside our heat pump? Well, it must have come from a heat engine somewhere else in the system. That's the only way we can ever get work out. Because entropy must always increase. And this is very much not entropy increasing. This is the opposite of that, but overall entropy must increase, meaning we need an even bigger heat engine to run any of our heat pumps. In order to run your air conditioning unit, which is a heat pump, you need a coal-fired power station, which is a heat engine. They tend to be a bit bigger. So there you go. Heat engines, heat pumps. There's a question about them underneath. I'll see you tomorrow.